Welcome to another special edition episode of Last Week in Quantum. This is the show where we review the top news in the world of quantum computing and its impacts on the worlds of cybersecurity, AI, and more. I'm your host, Rebecca Krauthamer, and today we have an expert in quantum security, one of my absolute idols in the world of quantum, Tom Patterson. He is the global lead of emerging technology security at Accenture. Tom, great to have you.
Oh, it's always good to be here with you, Rebecca, and I love this program. It stays topical, and there's so much going on, as you all well know, in quantum security that having a roundup like this is a wonderful way to approach it. So thanks for letting me be on and share my thoughts.
Oh, thank you, Tom, and thank you for sharing with us in the audience. And I think I'm excited to have you, and this is very timely. So last week, the news that we're covering this week is that the NIST conference, the fifth standardization conference, happened. It's a big deal because this is the year that the standards are finalized. And when we talk about the NIST standards conference for PQC, this is where the competition to push forward the new encryption standards that are quantum safe is where this is happening. So the conference happened last week. Tom, you were invited to the conference. You were also invited on your way to the conference to stop by the White House to give them the rundown, to do some briefings. And what I'd like to ask you is, how are you seeing things different this year versus last year? You've done a lot of these briefings. You're often invited to speak in DC. So, what changed this year?
Yeah, well, Rebecca, absolutely. This year is different. It has a different feel to it. It has since we were together in Davos to start the year. The question isn't, is this real? Now the question is, what do we do about it? And I've been involved in quantum security since doing some advisory work for the White House back in 2015, when it was still very much sort of, gee, maybe this is real, maybe it's not. This is a very different year, and in fact, this week is a good week to be on. And looking at retrospect, since it's been kind of crazy. I actually did do those things, the NIST meeting and the White House meeting, but flew into the White House from the UK, where I briefed the Ministry of Defense there the day before. So everybody wants to know what's going on and what to do about quantum security. And the NIST meeting last week, the fifth meeting from NIST, was just spectacular. It's a room filled with cyber and math and all sorts of people that don't otherwise get the spotlight, and it really had the world spotlight on them. This is a 10-year, more than a decade-long project that NIST ran to try and come up with these standards. And what they announced this week at the conference was threefold. But first and foremost, here are the new standard algorithms. These are the ones that are going to be standardized, and they're going through the process now. At the next meeting, they will actually be the standard and be downloadable. But here are the two that we're going to do. Here are the next two that are coming behind that. And by the way, this is going to be an ongoing process because we're still early days in figuring out all this new math and how it's going to work. And so there's a lot more work that's going to come out. But so that was the first and foremost. That was the key message from the conference. But second, I just can't take a breath without complimenting how this process works. The NIST team. Most people don't even know that NIST is doing this, but those that do sort of assume that NIST came up with this algorithm, and NIST tells us this is the one we're going to use. And in fact, it's just the opposite. What they did was they came up with a way to get the entire world to figure out what is the best way to approach and solve these problems, and then work through that and make it collective. So this was the best and brightest of the entire planet. And it was the culmination of a decade's worth of work to come to announce what they were able to announce this week. And it was really spectacular to be part of that, to be there, and really exciting times. When we talk to our clients here at Accenture, we speak of this meeting really as ringing the bell, the starter's bell, for so many organizations around the world that have been waiting for, once NIST has the answer, then we'll get started on the process. And that answer is now in. The bell has rung, and it's the starter's bell for lots of organizations around the world to get started.
Yeah, So many thoughts. I think that's a fantastic point. That a lot of people don't know that who aren't in the bubble, that it was NIST foreseeing this thing that we needed to upgrade our encryption, and then crowdsourcing from the best and the brightest of the world to come up with these algorithms, and then test them for since 2015, 2016. And I heard the NIST conference called the Super Bowl of cryptography, and it's really, these people are the celebrities of the math world and the crypto world. So people are in awe of these people that are getting up on stage and presenting these algorithms. And I don't know that people really broadly realize how big a deal this is. That we rely a lot on encryption, and this is the encryption that protects our data as it travels. Full stop. And that encryption is now this year being deemed obsolete, dead, and we have to make this migration. So it's a really exciting time. But Tom has a really storied background. He was part of that moonshot project with the White House. It was 2016.
It started. The question came from President Obama in 2015 of what are we going to do about this, and then it worked its way through the rest of the Obama administration, through the Trump administration, and then funded by the Biden administration. So it's truly a group effort here.
Yeah. When you were working on this, so Tom has a reputation for talking about stuff, knowing what's coming. So you were talking about Gen AI, and you were talking about quantum and quantum safe security back in 2016.
Yeah, to talk
And
about
so,
trying to explain people that the generative AI was going to come, and it was going to have risky aspects to it before anybody understood what regular AI was quite the challenge. But the same with quantum, people didn't get it. It was a paper exercise up until around 2015. They hadn't actually built quantum computers, and now we have multiple 1,000-qubit quantum computers in the cloud that anybody can come on and access, and growing even faster, and fidelity getting better. So all this has become real, and it's really good that people have around the world have been thinking about the security aspects of all this new tech and making sure that we're prepared. Which is again why last week was really a seminal week for everybody. I talked about these people that were there, as over 100 people that were there that have been working on this for a decade on the cryptography side, as real unsung heroes. Not just the
yeah,
NIST employees, but the people that just work for companies or that work for academia, or were just experts that that know a thing or two. That either they knew the math, or there was a power team there that was in there that looked at side channel attacks on any kind of an algorithm, and they were showing all they know about is looking at minute changes in power in order to able to break encryption. And they're showing, okay, so here's all the tests that you have to run, and here's why the implementation is so important. So it was really the best of the best in that room for 3 days, and it was really an exhilarating time to be there.
that's awesome. Yeah, I know our chief security architect came back and he was like, I got to meet this person and this person, and this is my idol. I read all this person their papers, and um, but yeah, and so, speaking of tell, foretelling the future, right? We were, as you said, we were walking around Davos in January, and your prediction, a lot of talk about Gen AI, a lot of talk about quantum, but your prediction for next year is that all the banners are going
Yeah,
to be
up and down the promenade is going to be quantum this and quantum that next year, because you're
yeah,
going to see the power of quantum computing, of quantum information science writ large. I mean, quantum sensing is going to really start to make the same kind of impact that Gen AI has made this year. We're going to start to see quantum information science making for next year, and then people will understand that there's two sides of these coins. There's the good and the evil, and so we've
right.
got to defend ourselves against these new capabilities that are now real. And luckily, in our world, in quantum security world, you don't have to know quantum physics. You don't have to know quantum information science. You don't have to have one of those giant chandelier things in a bath of freezing liquid in order to play. It's just math. You just need to do a different kind of ones and zeros that is not susceptible to a quantum computer. And lo and behold, now we figured out what that new way is. So it's a matter of implementing it. But one of the messages that did come out is that NIST is not done with this process. They made it very clear that they are going to announce the first of the standards for quantum security. in dilithium and kyber and crystals. So when they announced that as the first, but not the last. So what is really important that came up over and over again last week is we want you to get started. And people said, so what? What does that mean? Get started with what? Should we just download this new algorithm and plug it in and we're done? No, that was clearly not the message. The message is get started, figure out what your strategy is, do your quantum risk analysis, do your discovery to find out where your vulnerable encryption lies, and then start to come up with an architecture built around crypto agility, because you're going to have to keep changing the algorithms over and over and over for the rest of these coming years. Even this week, we saw new math coming out saying that a group of academics have found a vulnerability in the concept of lattice, one of the underlying mathematical principles that's being used for these new algorithms. So as things change, we need our defensive systems to be able to be agile, to be able to have orchestrated crypto agility built in. So this isn't a constant rip this out, rip that out, rip the next thing out. It's just put in at crypto agility and be able to adjust and have the best algorithms used in the best places based on the real risk. And that's where we all want to be in going forward. So when we say the bell has rung, the starter's bell has rung from NIST, it's do those three things: do your strategy, do your discovery, and architect your crypto agility so that you are ready to defend before that headline hits that adversary country or group now can decrypt all of your information and destabilize your entire economy.
Yeah, perfect point. And let's take it back just a step for the viewers, because this is a really important point. And you're just talking about you're known for kind of foretelling the future. You talk a lot about crypto agility. Same. This is what everyone needs to understand about encryption: crypto agility. So what is crypto agility? Crypto agility is it's a completely different way to handle our encryption than what we've been doing. And Tom pointed out, in the past, it is this idea that encryption is just more code, right? It's more math that kind of confuses the message so that someone who's not authorized cannot read it. And so that's baked into the code of our applications, or it's kind of pieced in places. And so in the past, you pull it out, you put something new in when you need to upgrade. And that's how encryption has worked. And encryption is meant to be broken. We see these news stories about, oh, here's a vulnerability there, and people kind of want to say, well, why would I upgrade? If things are going to be broken, why would I do it? And that's I think that just shows a misunderstanding of how cryptography works. And so when we talk about crypto agility, and yes, there was just a new paper that came out that shows a vulnerability in what's being released as one of the NIST standard frameworks. So crypto agility, Tom, tell us a little bit more about why it's so important and what it does.
So crypto agility, from a lot of reasons, is what I've been putting into our clients for years now. Even before I joined Accenture, that's the direction I've been pushing people, because there is going to be this flux in algorithms. We know that the one that we're using today for encryption in motion will be broken. So we know that that's not the one to use. So it's not a matter of, well, we'll just stay with that one for a while until the perfect one is built. As you point out, Rebecca, there's not going to be perfect. Perfect isn't available. It's not on the menu. We can't choose that.
Just yesterday, I was talking to, I won't name names, but if you know anything about cryptography, you know this person's name, because their name is actually
in cryptography.
in cryptography that we use.
At least their initial probably is, right? That's how it works.
Exactly. And they said, RSA, it's something that we use today, big one. He said RSA was never thought to be perfectly secure. It's just how much compute power do you want to throw at these algorithms, right? So exactly.
So we know that there's going to be these changes that are going to continue to come. NIST announced that this is the first but not the last. They announced that there's going to be continued research, and like I said, that some of the smartest people in the world were in there, proud as punch that they were able to kick the tires and find a weakness here or a vulnerability there. They really focused on, one of the NIST messages that came out of last week was focus on your implementation. It's not just the algorithm, but it's how it's implemented. What libraries are you using? How are you using those libraries? Because the weaknesses that were being demonstrated at the NIST conference were, in fact, implementation weaknesses more than algorithmic weaknesses. Now we see this new paper that came out today or this week that showed that there might be an algorithmic weakness as well on the lattice. But either way, that tells me that there's going to be flux. It's going to be a lot of change continuing in algorithms. We know we shouldn't stay with the one we know is broken. And so we should move to the best at any given time. What's the best that humanity has come up with? And how do we implement it in the best way? And for me, the answer that Accenture uses is crypto-agility, where you have the ability to put the right algorithm in at the right place. And in some cases, some of our clients, that's based on real-time risk. If a satellite is floating over a particular nation that has quantum capabilities, you want to maybe change to an algorithm that's less efficient but more secure. And then if it's going, if you've got something else that's just handling, tomorrow's lunch menu at the cafeteria, you can be less secure but more efficient. And so with these changes that are coming up, there's always going to be the need to put the right algorithm in to the right place. We're good at that today with keys. We can rotate the keys, when millions of keys a day if need be, in order to manage an enterprise. So we know how to do this, but we've never thought to do it with algorithms. And so that's what crypto agility brings, is we now need to also be able to use the right algorithm for the right time. It's pointed out that these are not one-for-one replacements. The key lengths are different. The processing times are different. The interaction is different. So you don't get the luxury of just saying we're just going to just swap out old for new and be done with it. You have to have a way so that you can match up. Encryption, public key encryption is all about talking to somebody else, sharing that secret with somebody else outside of your world. And in order to do that, there has to be a way to negotiate that with multiple different algorithms around the world. We're already seeing now countries doing very specific libraries where they say, okay, we're going to do this algorithm that NIST says, but we're going to code it. And we're only going to let our companies use our version of the code, just in case something goes awry. So being able to manage all the different algorithms and instances and implementations that are out there that are coming for the next decade throughout all this change, crypto agility is absolutely the cheapest, fastest, and most secure way to go.
Yeah, yeah, not well said. It's really about and again, I think most people don't realize that we don't really control our cryptography right now. We depend on all these disparate sources, and so it's really about. It might sound complex, but it's really about bringing it all into one place and saying, all right, this is the level of security I need to be able to communicate. If I need to communicate with South Korea or whatever it is, and making it simple and secure.
And there's simple is a key thing. There's another really happy. I love being in this part of security. I've always looked over the horizon. I've always worked on, hey, doom and gloom is coming. You better prepare. But in this case, this capability, the threat is very, very real, and we know it's around the corner. But the good side of this is that the defense for it is very realistic. If you plan for it ahead, it doesn't even cost much to do it the right way versus the wrong way. You can stop buying things that are going to be broken in a couple of years. So putting this in now up front really makes a lot of sense. But one of the benefits we see is we've, at least at Accenture with our clients, generally sort of the larger organizations of the world, we've set them up for it's going to take a long time to discover all of your vulnerable encryption. You've got a big organization, you've got enterprise all over the world. We've got great scanning tools out there that we deploy that can go out and find that. But that's a process that runs for a while. What they didn't expect was how quickly crypto agility can come in and actually provide real results very quickly. Even before all the scanning is done, we've gotten to results in less than a month in terms of finding people that had a steal now, decrypt later problem where they were actually losing fully encrypted data to an adversary and they needed to stop it. They thought it was going to be years until they could do something. And one of the benefits of crypto agility, it doesn't do everything all with the press of a button all instantly, but it does some things very, very quickly. So we were able to actually stem the losses right away that were out there by implementing crypto agility very quickly. And so that's another one of the benefits. It's just math, so you don't need to be a quantum physicist to defend against it. And B, once you get to the remediation side and you start to architect in a crypto agile solution, you can get real results very, very quickly. And sometimes that's really important just from a risk perspective. Other times it's important to be able to show your boss, hey, we've made great progress. We've taken all this off the table in terms of a threat. And that's a really, and we still have more to do, but we've eliminated these threats right away. And so those are the kind of things that we're quite proud of here at Accenture.
I think that's again such an important message, because I think a lot of people get stuck in the quantum's big, quantum's scary. There's a lot of other stuff that I understand that I can address. So let's put this off, assuming that there's no solution. But the reality is that there is. It's
Yeah.
simple. Let's get ahead of it. Let's protect real people's data, real organizations' data, real national security.
I just wrote an article about the NIST conference, and I used this term that I wasn't sure where it came from, but it turns out it was a Hemingway quote from 1926. It said that things happen gradually, then suddenly. He wrote that almost 100 years ago. And it's so true with this, because what we're seeing now is the same big organizations that said, well, we'll wait. Is the threat real? Does it really matter to us? We've got ransomware, we've got to fight. Yes, you do, but now there's this new threat. But now we're looking at, we've had this plan that Accenture's had for a number of years, where first you do the strategy, and then you do the discovery, and then you do the ecosystem, and then you get to remediation and start to defend. And we're having our clients all over the world now call us and say, okay, that's great. We want to do all those things. We want to do them all at the same time. So how quickly can we put this in and this? So we've gone from gradually to suddenly in terms
Yeah.
of looking for, we want to understand the problem, but we also need to remediate the problem and make the progress. And this is a really exciting time. 2024 is the year of making that big start in quantum security. And again, why I think next year in Davos, we're going to see the word quantum up and down the promenade.
Quantum and lights. Yeah, and to bring it back around to the initial question, what's different this year? So what you are seeing is that people are really starting to jump. I love that quote. Take the plunge and start really taking this seriously.
Yeah, two things we're seeing. One is that they're starting now, but two is that they want to fold all the future steps together and see how much we can do in parallel and get them to result even faster. And that's where our use of technology really helps. We use your QuSecure technology for parts of this, as well as others. But we also have invested quite a bit in building out a crypto agility lab, and building out a quantum security test lab, and building out a strategy compendium of best practices, the ways to be able to move these processes forward with our clients much more quickly than starting with a blank sheet of paper. We have a database of now almost 100 different common security products and what they are doing with their own journey on crypto agility and quantum security. And so what are they doing in terms of these new algorithms, and how are they going to do key management for them, and all the different ways that are going to be important for interactivity and throughput and performance. So we're able to manage those processes because we've been investing in this. And honestly, this started at Accenture because Accenture itself is a big, big hairy problem to wrestle with. We have almost 800,000 employees around the world, and a network of a lot of different networks put together. And so we knew that we were going to have to go through this. So a lot of what we built for ourselves to become crypto agile and quantum secure, we've now productized and made available to our clients to help them jumpstart. So it's really, like I said, it's a fun time to be this well prepared for the big push that's happening in 2024.
Well, so 2024, final question, quick one, taking it a step back. You head up not just quantum, related security, but you handle emerging tech security. So you handle space, you handle Gen AI. So we're at a cocktail party. I know nothing about all this. Imagine. And what would you tell the average person outside of the crypto space, uh, what they should be looking out for this year in all emerging cyber?
So I just what I always tell people is that it's always good to keep an eye over the horizon to see what's coming, and to understand that science changes things. Electricity changed things. Wireless changed things. There's a lot of things that started as science that suddenly now are just everyday. And I use the Chat GPT product announcement from 2 Decembers ago as the current example of, you never heard of it. If you thought about it, you didn't care about it. Now suddenly it's the most important thing you're working on. The same is happening with quantum next. People tell me that they don't care about space, and I tell them you will in a couple of years. You won't be able to do your job without part of that relying on what's happening in orbit around us. So all these science changes are coming, and the more you prepare and understand them, the more you can take advantage of all the benefits without getting stung by the threats that they bring. And that's what I do. And Accenture does a lot of things, but I'm proud that Accenture has an entire emerging tech security group that operates worldwide to help keep our clients on that cutting edge and able to use the new stuff quickly but safely.
Well, thank you so much, Tom, for joining us. It is always a pleasure. And thank you, everyone, for joining. And I hope you join us next week in Last Week in Quantum.
Thanks, Rebecca.